All right, let's dive in. We're going to talk about something you probably never even think to question. Something so basic it sounds kind of crazy to even ask. But stick with me, because by the end of this, you might just see your world a little differently. It all starts with one very simple question. Seriously, look at the table in front of you right now. Or, your desk, whatever your laptop is sitting on. It's real, right? I mean, of course it is. You can touch it. But what if I told you that according to physics, there's a totally different table right there in the exact same spot? This is what the physicist Arthur Eddington famously called the tale of two tables. So on one side, you've got the manifest table. This is your common sense table, the one you know and love. It's solid, stable, you can put your feet up on it. It's what the philosopher Wilfrid Sellars called the manifest image. But then you have the scientific table. And this thing is wild. It's what physics tells us is really there, a swirling cloud of atoms, almost entirely empty space, all held together by invisible forces. So which one is it? Which one is the real table? Okay, so how do we even begin to sort this out? We can't just go with our gut feeling. We need a tool, a clear philosophical test that helps us figure out what gets the stamp of real in our universe. And lucky for us, we can borrow a really powerful idea from way back. I'm talking Plato's dialogue, The Sophist. It's called the stranger's dictum, and it is so elegant and simple. It just says this: to be real is to have the power to affect something, or to be affected by something. That's it. To cause or be caused. Let's call this our ultimate existence test. So let's put our everyday common sense table to the test. Step 1, does it cause things? Oh, for sure. It's holding up my laptop right now. It'll stop a tennis ball if I roll it. Check. Okay, step 2. Is it caused? Is it affected by other things? Yep, I can push it. Gravity is pinning it to the floor. I can scratch it. So check and check. It passes with flying colors. The manifest table, our table, is real. But hold on. The story's not over yet. Okay, so our table is real. It passes the test. But now another problem pops up. Some philosophers would jump in and say, sure, it's real, but it's only real in your mind. The idea is that its very existence depends on us being here to perceive it. And this is a really tempting idea, but it can lead you down a rabbit hole, a kind of mind-only trap. There's a name for this trap, the transcendental fallacy. Whoa, big words, I know. But all it means is confusing what is, that's ontology, with how we know what is, that's epistemology. Here's a perfect example to make it super clear. It's like saying Ramses II couldn't have died from tuberculosis because the bacteria that causes it wasn't discovered until the 1880s. That's nuts, right? The bacteria existed whether we knew about it or not. And it's the same with the world. It doesn't need our minds to be real. The philosopher Hilary Putnam had this amazing way of putting it. He said that realism is an impossible attempt to view the world from nowhere. Think about that. We can't just step outside of ourselves and see reality from a God's eye view. It's impossible. We are always stuck looking through our own human eyes with our own human brains. But, and this is the key part, that doesn't mean the world out there isn't real. It just means our window onto it will always be, well, human-sized. So let's circle back. If our common sense table is real, and it's not just in our heads, then what about that weird scientific table made of atoms and empty space? Does that mean science is just telling us our senses are liars? No, not at all. This is where we need a bit of a mind shift. The key is to stop thinking of science as replacing common sense and start seeing it as refining it. This is a perfect illustration of what I mean. Let's take the idea of motion. To us, in our everyday lives, it feels like an event that needs a push or a pull to happen. But physics comes along and refines that. It says, well, actually, motion is just a state. The only thing that needs a cause is a change in that state, what we call acceleration. And then it goes even deeper. We think of acceleration as just speeding up, right? But physics refines that again and says it's any change in velocity, which could be speed or direction. See what's happening? Science isn't saying our first idea was stupid. It's taking that raw common sense idea and sharpening it, making it more precise, more powerful. So let's pull all of this together now. What we've been looking at isn't some epic battle between two competing realities. It's not common sense versus science. It's actually a single ongoing process of getting to know one single reality a little better. And that brings us to the big answer, the punchline. Which table is real, the manifest one or the scientific one? The answer is both.
but not as two separate things. It's better to think of them as two different descriptions of the same thing. They're like two different maps of the same city. One is a simple subway map that gets you from A to B. That's our manifest table. The other is a super detailed topographical map showing every street and building. That's the scientific table. Two different maps, one city.
And this whole way of thinking, this whole approach, it rests on a really important, kind of humble philosophical idea. It's called fallibilism. And all it means is that we have to accept that our knowledge is never perfect, is never 100% locked in and certain. It's always a work in progress, always open to being tweaked, corrected, and made just a little bit better. And this brings us right back to our guy, Wilfrid Sellers, who just nailed it with this quote. He said, human knowledge is rational, quote, not because it has a foundation, but because it is a self-correcting enterprise, which can put any claim in jeopardy, though not all at once. Wow, think about that. Our knowledge isn't strong because it's built on some unbreakable bedrock. It's strong because it's constantly checking itself, fixing itself, and getting better. That's the real engine of human progress. So what are the big takeaways here? Let's boil it down. Number 1, your ordinary, everyday knowledge isn't wrong or silly. It's the foundation. It's where everything starts. Number 2, science isn't here to tear that foundation down. It's here to build on it, to refine it. And number 3, this whole thing is a virtuous circle. Common sense sparks a scientific question, science refines our common sense, and our improved common sense leads to even better questions. It's how we learn.
And that leaves us with one last really cool thought to chew on. Think about it. So much of what we call common sense today was once mind-blowing radical science. The idea of tiny invisible things called germs, a world that spins around the sun, that was nuts at the time. Now it's just obvious. So it makes you wonder, doesn't it? What part of your common sense world, what thing you take for granted as totally obvious today, is just waiting to be refined by the science of tomorrow?